Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about what is GEMDAS. GEMDAS. So in order to start with that, let's start with PEMDAS, which I'm sure you're way more familiar with, right? Please excuse my dear Aunt Sally for what we'll never know. But the P, if you'll notice, is the only thing that's different. P stands for parentheses, or as most people like to call it, parentheses. And then, of course, exponents, multiply, divide, add, subtract. So you start with parentheses, start with something that's inside the parentheses, and you might have a whole nother PEMDAS, a whole nother one inside of that. Right? And it could keep going, right? Could keep going inside forever and ever and ever, and you could just have millions and millions of rows. But hopefully you had a teacher that was nicer than you, nicer than that to you, sorry. And she didn't give you too many of those. So let's look at an example of how PEMDAS works here. Before we can talk about GEMDAS, if you don't fully get what PEMDAS is, it's not going to matter anything else I'm saying. So let's do an example real quick. Let's say I have 2, and then 3 squared plus 5 minus 7. All right, so PEMDAS. PEMDAS, and then inside the parentheses, I have a parentheses, I have another PEMDAS. Okay, so let's go down the list. You would start with the P here, and there's no parentheses inside the parentheses, so I don't do anything else there. But I do have an exponent, so then the first thing I do is 3 squared, which is 9, plus 5, minus 7, leave everything else the same, and then I'm done with that. Now I don't have any multiplying to do, right? So technically I do outside of the parentheses, but I'm still inside this P for PEMDAS. I'm still inside the parentheses, so no division, but I do have some addition here. So 2 times 9 plus 5 is 14, minus 7, and so now I'm done with that, and there's nothing else to do. I just have 14. There's nothing I can do with that. There's nothing to add, subtract, multiply, divide, exponents. There's none of that, so no subtraction, and I'm done with my parentheses. So then I move on to the E, this E, which I didn't have one, right? Nothing outside of the parentheses as far as exponents go, but I do have a multiply, right? 2 times 14, so it's going to be 28. Done with that. No dividing. Oh, sorry, minus 7. No dividing, no adding, but I do have a subtraction. So 28 minus 7 is 21. 9 plus 10, 21. So 21 is the answer. And that's how you do PEMDAS. But here's the problem with PEMDAS, right? This is why GEMDAS is better than PEMDAS. PEMDAS is old news. It's garbage. GEMDAS is a million times better. And if you hear me talking about GEMDAS in the future, it's because I've officially drank the Kool-Aid and I now get why GEMDAS is better. Inside of G, which stands for grouping. Oh, I cannot spell. Hold on. Grouping. You could have another GEMDAS, right? So it's pretty much the same thing, except what happens when I try to do PEMDAS, right? So let's compare PEMDAS versus GEMDAS here. PEMDAS, and let's say I have 2 times the square root of 4 plus 5 minus 7. So very similar to the last example, a little bit different numbers. But there's no parentheses, right? This is not a parentheses. Parentheses. Parenthesis. Parentheses. It's not a parentheses. So I don't know. I guess there's no parentheses, so I go on to exponents. All right, here's an exponent. This is an exponent. It's an exponent. It's an exponent, right? Powers, roots, and anytime you have to flip a number, those are all what's considered exponents. So no parentheses, just an exponent, but I can't take the square root of 4 plus 5. So there's nothing else to do because I can't take the square root of 4 plus 5, so there's no exponents. No multiplying, because I can't multiply 2 by something inside of a parentheses. And no division, no addition, excuse me, and no subtraction, because I can't take 7 and subtract it from some sort of square root thing multiplied by a number. So there's nothing I can do. And then enter GEMDAS. Da, 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 da. GEMDAS. So this is a grouping. This would fall under a grouping. It's a way to group numbers, right? So notice PEMDAS specifically is for parentheses, which groups numbers, but it only works if I use a parentheses. It's only one type of grouping, whereas G is all the groupings, all the way you can put numbers together. So inside of my GEMDAS, I have a GEMDAS, right? And I would have 2, and then I would add. So I'm going to add inside of my GEMDAS first. Boom, boom, right? No G inside of the G, no E, no M, no D, no S. Just an addition. 2 times the square root of 9 minus 7. Right, now I'm done with my grouping because, there's nothing else to do with 9. 9 isn't going to be added, subtracted, multiplied, divided, or taken to the power of any other number. So I'm done with that. And then I move on to E. Well, remember what I said earlier? This is an exponent. That's an exponent. So now I'm going to evaluate my exponent. The square root of 9, exactly, you guessed it, is 3. 3, boom, done. Oh, minus 7. I keep forgetting that, minus 7. Sorry, little guy. So then I have 2 times 3. Oh, wait, I mean to circle that. I have a multiply to do. 2 times 3 is 6. All right, done with my multiply. No division, no addition, just subtraction. 6 minus 7 is the opposite of 7 minus 6. 7 minus 6 is 1. The opposite of 1 is negative 1. That is my answer. So I can evaluate, if I use GEMDAS, other kinds of grouping besides just parentheses, right? So PEMDAS is just fine until you get to about, I don't know, geometry. Maybe even as early as Algebra 1. Because really you talk about exponents in Algebra 1, and you can group exponents without using a parentheses. So yeah, basically if you're in like Algebra 1 geometry or higher, PEMDAS is not something that belongs in your vocabulary anymore. Just GEMDAS. GEMDAS. And the way you can remember it is, of course, gem. It's a gem. Got a gem here. Shiny gem. And then DAS for DAS, like dazzle, right? It's a dazzling gem, right? So that's why it's a million times better. PEMDAS. What's PEMDAS? That didn't even mean anything, right? The DAS could be dazzle, but then what's PEM? A PEM particle, right? It's a PEM particle that dazzles? No, it's a gem that dazzles. Okay, it's a gem that dazzles. GEMDAS. And you could say greatly instead of please. You could say greatly excuse my dear Aunt Sally, right? So again, I have no idea what Sally did, but whatever she did, apparently we need to greatly excuse her for whatever it was. Maybe she tooted or something. It just really stunk. But that's GEMDAS. And before I go, I'm going to show you another example, but I also want to talk about a couple different kinds of grouping, because you might have thought at some point, like, okay, well, what exactly would be some groupings? Well, let's talk about it. So actually, I'm going to switch from red. I've been using red for too long. Let's switch to blue here. Grouping. So obviously parentheses, right? So parentheses, that's a type of grouping, right? Which is, why we have PEMDAS. And if you have parentheses, that could look like this. Or it could be brackets, which are basically parentheses. Or it could be what's called curly brace brackets, which are these squiggly looking things. And those are all, in my opinion, parentheses. Now, technically speaking, you might call them, brackets, curly brace brackets, and parentheses, but you get what I'm saying. They're these little squiggly or blocky things that, group numbers. So you have those. And then also, technically, division. Division is a type of grouping that you wouldn't need a parenthesis parentheses for. So for instance, if I said 3 plus 7 over 1 plus 4, right? I wouldn't divide 3 and 1 or 7 and 4 first. I would add 3 and 7, get 10, add 1 and 4, get 5. 10 over 5 is 2, equals 2. So division, right, the division bar is actually a way to group the numbers. If you have a division bar, everything on top is grouped and everything on the bottom is grouped as well. So that's another type of grouping. Then you have trig functions, right? So if you're in algebra 2, even geometry, right? Geometry, you talk about trig. That's the first time really that you unpack trig. There's a whole unit on it. So grouping, you have trig functions, right? So trig functions would be sine and cosine, tangent and cotangent, secant and cosecant. Right? So those are your trig functions. Those are types of groupings. And then of course you have the one we just did as an example. Can't leave that one out. It's a square root. If you have a square root, you can square root a bunch of stuff. Or actually, you know what? Let's be more vague here, more general, I should say. Roots. Let's just say roots. So for roots, you could have a square root, a cube root, that's supposed to be a 3, and, 4 or more. But anything under that radical is all together. It's all grouped together. And I'm trying to think what else. Well, let's just say other. Let's just say other. Other stuff. Other stuff. So other stuff could be like logs, logarithms is what I mean there. And just other functions. So you have logarithm functions, exponential functions, which normally you wrap around with a parentheses anyways, but I'll go ahead and list them there. Logs, exponentials, complex numbers, right? I, E, limits maybe. I don't know, just other stuff, etc. That's why it's spelled ETC. Okay, so those are all the different groupings. And not all of them, because that's why I left an etc. because there's other things in there. If I miss any that are really important, let me know in the comments. Because I kind of thought about this. I was writing them down. I was like, I pretty much think I've gotten all of them with all this right here when I was working on making this earlier. So that's all of them there. And I want to end with one more example real quick. Just to kind of look at what this would look like with one of these other ones. So let's do another one with division maybe. So 3 squared plus 1 over, let's say the square root of 9 plus 2. I don't know, something like that. I'm actually making it to where it's very similar to the one I made earlier in that it's going to be the same answer. So you do GEMDAS, and there's actually 2 different G's because each top and bottom is its own G. So I'm going to kind of expand to the left and to the right. A GEMDAS to the left and to the right. GEMDAS. All right, so on the top, I have an exponent. Right, so I'm going to do that first. 9 plus 1. Right, so that's gone. And then on the bottom, I also have an exponent. Nothing inside of the stuff, right? So nothing inside the radical other than 9. I'm going to have an exponent, though. Square root of 9 is 3. Right? Excuse me. Hold on. Ah, man, I hate it when that happens. I had a sneeze come on, but it just didn't come out. Ooh. Ow, my nose is burning. So 3 is the square root of 9. That's an exponent, so I'm done with that. So that's just 3 plus 2. All right, I'm going to go down from here. I don't really want to cram the space. So then no multiply, no dividing, just adding inside of my G for GEMDAS. And of course, no subtracting. So 9 plus 1 is 10. 3 plus 2 is 5. And done with the addition, done with grouping, no exponents, no multiplying, but I do have division because that was the type of grouping that was just implied. Implied, implicit. I don't know. It was an M word I was looking for. But you know what? It's okay because I math. I can do math. 10 over 5 is 2, of course. So that would be the answer. And I'm done. And that's it. Awesome. So if this video was helpful, go ahead and smash that like button if you want to see more like it. Hit the subscribe button, turn on notifications. Hit me up in the comments below. I want to know what video you'd like to see, what topic, any topic in math, ranging from pre-algebra to Calc 3, and everything in between, whether it's a high school or college class. Just let me know in the comments what topic you'd like to see a video on, and I will do that for next week, or I'll do it for some time during this week. Maybe I'll do an extra one. But as always, videos are coming out, and I have them scheduled to come out on Monday at 4. Consistency is a thing that I'm working on, but that's my goal, is that you can expect a video to come out at 4 p.m. So check that out. Oh, also, another notification. Next week is March. Yay, March Madness. So I'm going to plan on doing a whole series in March on factoring, another factoring series. I have a series on factoring that I did a while back on just factoring when there's nothing in front of x squared, aka it's 1. There's 1, x squared. But I'm going to do another series on factoring where there's something in front of x squared and what that looks like. I did a video before, and I'll put the link in the description below for it. But a video on how to factor when you have something in front of x squared. So like, I don't know, 2x squared plus 5x plus 2, right? That's factorable. And how to do that. It's called Two Truths and a Lie. So I'll put the link in the description below. But check that out. And I'm going to do a whole factoring series on that because that's one of the topics that I get asked about a lot is, how do you factor when there's something in front of x squared? So I'll be making a whole series on that very soon in March, and I'll let you know when the first video comes out. I'll let you know what the details of that series are going to be, how many videos, what they're going to look like, what the format's going to be, and all that kind of stuff. And I'll keep them down to about 5 minutes, give or take a few minutes. So like no more than 7 minutes per video. But check that out. That's coming up. And also, if you haven't gotten my free guide, 5 math mistakes everyone makes and how to avoid them, you can grab that on my website for free, myersmathematics.com. And I hope to see you soon in another video. Have a blessed day.